There we go, maybe. All right, yeah, so welcome to class. Hopefully you got the new notes. Again, sorry about the about kind of jerking you back and forth there on which notes we're using. As I was preparing the notes for lecture today, Dr. Baker's notes, I wanted to go with some different examples. So that's why we switched up the notes to a different version, and these are kind of looking like maybe the first few chapters we saw. So we're going back to those just for this chapter. I think we'll get into chapter 9 a little bit today, hopefully, and for that we'll be back to the normal notes that were posted on Carmen. So I think we should be all set. I don't think I have any announcements for you. Homework is due next week, I guess. I sent out an email yesterday with a few details on the exam that's coming up. Any questions about homework or the exam or anything else? Yes, sir.
Do we still get to bring a sheet with formulas on it or anything?
So you do not get to bring a sheet with formulas on it. That was my that was my fault for saying that before I checked in with Dr. Baker. So yes, I know. That's his preference, I guess, is for you guys to have all that stuff in your head. So you got it already. That's right. That's right. Good question. All right, well, here we go. Let's go ahead and get started with chapter 8 here. So just kind of again, I like to keep kind of trying to connect what we're getting ready to do with what we've already done, kind of how it's similar, how it's different. So in part 1 of the text, which was all the chapters that we've done so far, chapters 1 through 6, we were looking at graphical displays. Started off with, we did numerical summaries. We started looking at things for 1 and 2 variables. We got into regression, and then just last time we talked about 2A tables with categorical variables. And in all those examples, we just sort of said, here we have some information and let's do something with it. We can display it, we can summarize it, we can look at relationships. And now the next 2 chapters, we want to talk a little bit about how we get that data. So we're not going to get into anything too crazy here in this class, just kind of some introductions on good methods of collecting data. So thinking about how we get that, and then also, of course, thinking about, is all data that we can collect, is it all equally good? And I'll let you think about that one here for a minute. So it's kind of a motivating example here. Suppose that I want to know something about the distribution of majors across campus. So that's a categorical variable. You have lots of categories in there. And I want to know sort of where are most people, what do most people have their major in? And so to do so, I can ask all of you guys in this room what your majors are, and make a list, maybe make a pie chart, maybe make a bar graph, something like that, to kind of give me an idea about my question here. So is this a good strategy, and if so, why? Or is this a bad strategy, and if so, why is it a bad strategy? Any thoughts from you guys? Yeah.
I think it would be a bad strategy because not all majors have to take statistics, so this is only be most people, like majors that have to take statistics.
Yes, exactly right. So the comment was, this is definitely a bad strategy because people in this room are people who are taking, obviously, an intro stat class, and that's not all majors have to take an intro stat class. So maybe some people aren't represented in here. So this is not a good strategy. So let's write that down. This is a bad strategy because there are certain majors who are not required to take a stats class. Those are such boring majors, aren't they? Those are the people that don't have to take stats. But anyway, the point is that, if for those majors, they're just not represented in here. So I'm sort of missing out on a big group of people. So I'm missing out. So there's sort of some people that I just won't see if I just ask the people, you guys in this room, what your majors are, and kind of go with that way. So kind of maybe that's kind of an extreme example, but in general, we want to think about how can we get good data. So starting off with some terminology here. This is definitions that we'll be using in these chapters for sure, but also as we move into later chapters, sort of the meat of this class. These are some very important definitions. So First thing we want to talk about the difference between our population and our sample. So first of all, the population in a statistical study or any kind of a study is the entire group of people about who we want to get information from. So that's everybody. So that's who I want to make my statement about. So in that previous example, if I want to know something about the distribution of majors at Ohio State, again, I'm trying to say something about everybody at Ohio State, so my population is all Ohio State students, for example. But of course, in general, it's not going to be possible to ask every single person in your population. So it would be a big waste of time for me to try to get the answer from every single person here at Ohio State. That would take a really long time. So instead, when we're actually doing some sort of a data collection or a study, what we'll do is we'll take a sample, which is some subset or some part of that population, and those are people that we actually collect information from. So that's kind of the key thing there, is that we actually collect information from our sample. So again, population is kind of the larger group that we're interested in, but for a variety of reasons, maybe kind of scale or just time, we're not able to talk to everybody, so we take a smaller group of that population and we actually collect information from them. And then something called a sampling design describes exactly how to choose a sample from the population. So again, if I'm interested in everybody at Ohio State, how am I going to choose people to ask them what their major is so that I can get good information there? And then finally, a sample survey is something that selects the sample from the population. And for a sample survey, we need to specify exactly who our population is and what we're trying to measure. So again, sample survey for the sort of simple example, the population is the Ohio State students, and what I wanted to collect information on was their major, something like that. And then this is kind of the key idea here, is that we want, and this probably makes sense, if you kind of the reason that first one was bad, if I'm only asking you guys in here about majors at Ohio State, the group of you guys in this room is not necessarily representative of the entire university. So in general, kind of keeping that in mind, we want our sample that we choose, the people that we get information from, to be as representative of that population as possible. And then it's not so easy always to do that. So if you want to take, if you have some time later today over the weekend, if you want to look at some good sample surveys here in the United States, there's some really good ones there. I think there's hyperlinks in your notes. I'm not going to get into any details there. But so kind of thinking about this idea of how do we get good data, I think it helps to start off by thinking about how we can get bad data. Because it is often very easy to sample badly and get a sample that's not representative. Same example once again, if I'm interested in saying something about all Ohio State students, well, it's very easy for me just to ask all of you guys in here. But that doesn't necessarily mean that's a good thing to do. So another term, a definition here for you is this idea of a design being biased. So if I'm designing a study, if I'm collecting information, whatnot, that design is biased if it systematically favors certain outcomes over others. So if it systematically overestimates or underestimates whatever I'm actually interested in. So example I put up here is last fall this class was really fun because it was the election season. But again, thinking about a biased study would be as if I was looking at an election poll if I'm at one of the party conventions. That's just not going to be a very accurate snapshot of what the entire country is going to do. So let's look at a couple ways of collecting information in badly. So these are the ways you do not want to do, but kind of wanted to kind of show you what a good way is by first talking about what a bad way to do this is. So our first bad sampling method here is called a convenience sample. And kind of just like it sounds, this is a case in which we collect information from the people that are easiest to talk to. So convenience sample, I'm sampling people who are convenient for me to get a hold of. So example of this maybe, see if you can tell me what's wrong here. If I want to find out about how people in Columbus here feel about the new Scioto Mile Park downtown, maybe if I'm a local news reporter and I'm walking around the park and interviewing a group of people who are there on the opening night, what's wrong with that sampling method? Yes, sir. Exactly right. What was the end there? Right. Okay. So people who are at the park on the opening night, probably big fans of the park, right? Because they're already there. So let's write that down. And so why is that a problem? Take that one step further. Yeah.
It's not an accurate depiction of the residents of Columbus.
Yes, exactly right. So this is not a very, if we're only talking, again, the question looking back there is, if we want to kind of find out how people feel about this new park, talking to people who like the park is kind of is not a very good way to represent the how all Columbus residents feel. So again, we want to know what all Columbus residents think and if we just talk to these folks, that will not be a very representative sample. So that says we want to know what all Columbus residents think about the park, and just asking people who are there at the park. This does not give us a very representative sample of all Columbus residents. All right, so again, that's a kind of a simple case there of something called a convenience sample. When I'm talking to people who are convenient for me to access. And the big idea there is that that's probably not going to be a very representative way to sample the population. Very good. All right, so that's our first bad way to sample. Second bad way here is something called a voluntary response sample. And this is a case where the people who I hear from in some way have elected to give me their opinion. And this is likely to be biased because again, people with strong opinions are most likely to respond. So, again, best understood probably by way of an example. Thinking about a local news station, if a local TV station has a call-in poll of public opinion on issues during their 6 o'clock news and their 11 o'clock news, the results are usually given. So at 6 o'clock they say, please call in and tell us your opinion on whatever issue that I'm looking at here. And then they announce the results at 11 o'clock. They usually say something like, the residents of Columbus believe ... and then give whatever results they got from the phone-in poll. So what's wrong with this sampling method here? Yeah.
Only represents the small group of people who care or actually watch the news at 6 o'clock.
Right. Okay. So first of all, not everybody is watching the news at 6 o'clock, right? Yeah. So this only includes I'll steal your words there. People who care enough to watch the local news. Absolutely, that's a big problem. What else? Anything else you guys can see? Yeah.
Wouldn't the broadcasters pick and choose which ones they want to actually broadcast anyway?
Good. Yeah. So wouldn't the broadcasters choose which ones they say? Well, that is very possible. Yes, but we would hope that they would not lie, I guess, about the results that they got. So yes, they could sort of say, well, they could sort of pick and choose the responses they wanted, but we're going to hope that they're honest, I guess. Although that's always something to be careful about too. Yeah. Exactly right. So not everyone's going to call in. And then who is going to call in of people who are watching? Yeah.
The people who are confident in their opinions enough to call in, so they feel comfortable talking to someone about their opinions.
Exactly right. Yeah. So it's first of all someone who has to have a strong enough opinion to want to call in, but then also those people who are sort of confident enough in their opinions to actually make that phone call and talk to someone about what they think. So not everyone's going to call in, and the people that do. Probably have a strong opinion. So there were a few hands I didn't get to. Did you guys have anything else to add? Okay. All right. So first way to sample badly is taking a convenience sample. This is sort of like that. I'm allowing people to call in and tell me what they think. And again, if I want to say something like the residents of Columbus believe, this is not a good way to do this. What I could say is people who watch the local news at 6 o'clock and care enough to call in believe, and then ... So again, if you're trying to say a statement about all people in Columbus, this is not a good way to do so. So both of these two things have something in common, and that is this notion of personal choice. So in selecting the sample. So first of all, I sort of chose who was easy for me to contact if I'm doing a convenience sample. The news reporter they chose that they just went to the park and asked people at the park what they thought about it. And then the other way, the voluntary response sample. Is sort of the other way around. The people who are part of the sample are choosing to be a part of that group. And we saw that in both of those cases, it does not give us a very representative sample of what's going on here. So, kind of thinking about the other side of that is if we have some sort of impersonal chance or some sort of unbiased way or objective way of choosing our sample, that will give us a more representative and a better sample. So this leads us to our idea of how we do want to sample. This is our good way of sampling. Excuse me. And this is called a simple random sample, and we'll often abbreviate or give a little acronym there of SRS, simple random sample. Excuse me. And my definition here is just that if I want a simple random sample of size n, so this will be our sample size. And that's almost kind of, we've sort of already been doing that, but that will continue to be our notation. Whenever you see an n, that means how many people are in your sample. So a simple random sample of size n consists of n individuals from our population, and we're choosing them in such a way that every group of people that's of that size has an equal chance of being selected, and kind of think about that just means that everybody has an equal chance of being selected to be a part of my group. And so kind of thinking about this is a more of an impersonal way to choose my sample. And you can kind of think of this is sort of like drawing names out of a hat. It's kind of the basic idea is that if I have everybody that is in my population, if I have their name in a hat or something, and I just pull out the first, if my sample is going to be 10, if I pull out the first 10 names, that's kind of everyone's having an equal chance of being included in that group. All right, so simple random samples. This is the definition, but maybe you're wondering how do we get these? How do we get a simple random sample? And most of the time we'll use technology to get a simple random sample. But I wanted to go through a quick example of showing exactly how this selection works, even though it is kind of tedious and slow. I want to kind of show you exactly how it works. So on the last page of your notes, you have I've included a copy of Table B, which is again from your textbook, and that is here what we call a table of random digits, and it's just a big long string of the digits 0, 1, 2, 3, all the way up to 9, and each entry in the table is equally likely to be any of those numbers, and choices are sort of made independently there of each other. So again, I think the word random is thrown around a lot today, and again in this class we have a very sort of specific meaning for what a random sample is, and that would kind of, or what the word random means, and again here it means that each entry is equally likely to be included in any one particular spot. So you don't have to worry too much about where that table comes from, but just the idea that as you're going through that, it's kind of a string of truly random numbers. So to use this table to choose a simple random sample, we want to do two things. Is first give each member of the population a numerical label that has the same length, and we'll go through an example. I'll show you what I mean by this. And then to choose our simple random sample, we kind of pick any line out of that table and read off the successive groups of numbers of that size. So again, I think an example will be most helpful here to show you exactly what I mean. And then just some cautions there of how to do this. So for my example here, I'm taking Fisher College of Business here, and this is probably from a year or so ago. And I want to send 5 faculty members from the Fisher College of Business to a national conference. But again, I want to be fair, so I want to sort of give everybody a chance to be a part of this group that I select. And kind of thinking this is, I want to take a random sample of five people. And then here's a list of all my faculty members. So these are all the people that I've listed in that are on faculty there at Fisher. So again, I'm going to pick out line number 116, and I could have chosen any other line, and that would have been totally fine. So what I first want to do here is I want to first give everybody in my population, which is down, this is my population. I want to give everybody a label of the same length. And here I have, if you count those up, I have 25 people, so I want to give everybody a two-digit code or label. So I can choose 01, 02, and I can do that for every single one of the people in my list here. I'm going to do that just for, so you can see what I'm doing here. 12, 13, okay, so for everybody in my population, the first thing I want to do is give them a label that has the same length. So just 2-digit labels here. And that's why I'm doing 01 and 02 instead of just 1, 2, 3, because eventually I have more than 10 people. Okay, so then again, I want to go to Table B and pick out a line. I've chosen line 116 here, and then I want to start. Counting, looking at the however many digits I've used for my labels. So here I have 2, looking at each succession of 2 numbers. So I have 14, I have 45, I have 92. I have 60, I have 56, 45, 60, 56, 31, 42, 48. So I'm just kind of chopping up this list like so. And 03, 71, and so on. So instead of writing out all those, I'm just going to divide this list up into my two-digit labels. So if I would have had more than 100 people in my list, I could have used 3-digit labels, and then I would just be dividing that up into every third number I would put together. And then, so once I've done that, again, the last step of our thing says that your sample contains the individuals whose labels you find in the table. So what do I mean by that? So now I'm going to go up here in those two-digit things that I've paired off together and pick out the numbers that I have written that I've put down as labels in my population. So again, we have a 14 in our list. We don't have a 45. We don't have a 92. No 60. So I go over here, and 3 is the next one that I have in my list. Now I have a 10, and here's a 22, and there's a 6, there's an 11. And so you're just picking out the labels that you do actually have in your list. And then I'm going to choose the first. So if I want a sample of 5, I'm going to choose the first 5 numbers that I see in there. So here's my first one. Here's my second one, third, fourth, and fifth. So the labels that I chose here are number 14, number 3, number 10, and number 22, and number 6. And so my simple random sample is going to consist of those 5 faculty members. So my simple random sample is going to be the 5 people I have circled here. And this is of 5. So that's how we can find one of these by hand. It's kind of takes a long time, right? So again, we'll default to technology most of the time when we're doing this, but again, it is very, very good to know kind of how this is done. So do you kind of see the difference of what we're doing here? The difference here is that I have sort of impersonally chosen which 5 people are in my sample. It's nothing that I have no choice that I've made that gives me this sample. I guess other than I've chose line number 116 on the table. So that was the one choice I made, but that's going to be an okay choice. So if you chose a different line, let's say you chose, I don't know, line 124 or line 143, you would get a different simple random sample of 5 people from this list, and that's okay. Any questions on what we've done here? Yeah.
What would happen if you didn't get enough for your sample?
Ah. So what would happen if you didn't get enough, if we wanted a sample of like 8 or something like that? Yeah, so if we didn't get enough, if we didn't get 8 numbers in this list that were in the right range, just spill on to the next line. So if you need more than 5, then you could go to line 117, which starts off with, well, I'm not going to write that out, but you spill around to the next line there to continue that. Very good question. Yeah.
On exam, would you tell us which table line you want us to use, or like give us the specific table line?
Yes. If we didn't do that, there wouldn't be just one answer that was correct. It would be, for whichever line you chose, we would check that, but we would probably tell you which line to use. Yeah. But yeah, so if you're doing this in your homework, comparing notes with a friend or something, if you guys have different answers on what your random sample was, that's to be expected. You wouldn't necessarily choose the same line unless you were working together. So that's okay if you get different answers. So thinking back that our main goal here of taking a sample is that I want to say something about the larger population, right? So again, all these examples, we can't actually talk to everybody in our population, so we take a sample, but we want to use that information to say something about the larger group there. But of course, it's almost never possible or even practical to get everybody in our population. And so then this leads us to the idea of something called inference here. This is something that we'll talk a lot about here in the remainder of this class over the semester. Is that drawing conclusions about our population based on the information that we sample. That's called inference because, again, we're inferring or hypothesizing or making a statement about the population based on which is something that we don't know, right? We don't know. We haven't talked to everybody in the population. So we make a statement about that based on what we do know from our sample. So this is kind of where we're going in the next part of this course. And then just a couple, if you're wondering why is this random sampling so good, again, kind of that idea of that it's an impersonal way of choosing our sample is the key thing. But again, that's going to give us the best chance at having something representative of the population. And then in chapters 10 and 12, we're going to get into talking about probability, and there we'll kind of see again that the laws of probability, there's some theoretical things going on there that allow us to make a good inference or make good statements about the population if we have a random sample. So again, we're not going to spend a lot of time talking about other sampling methods, but there are very, very many of these. You will probably never, if you're reading a news article or something, you read a survey or a poll or something like that, they probably have not done simple random sampling. That's kind of the building block off of which these other good methods are built. So there's something called stratified random sampling. So this is something you would want to use if there's sort of these important subgroups in your population. You could take a random sample from each group separately. So if I want to do that, my definition here is I'll first classify my population into groups of people that are similar or that groups that sort of make sense, and those are called strata. And then I'm going to choose a simple random sample from each one of those, and then put them all together to have my full sample. So let's think about an example of what this would look like. So again, going back to this campus example here, if I want to talk to people, students and faculty at Ohio State to determine their satisfaction with GE courses, I take a random sample of 250 students and a random sample of 50 faculty members, put them together. So why is this a stratified random sample? Who can help me out there? Yeah.
Are there a student or faculty groups?
Mm-hmm. Yes.
You wouldn't want to only take the students.
Exactly right. So I have these two very sort of distinct groups, right? I have faculty members and I have students, both of whom will probably have very different responses to my question here. And so I want to make sure to include both of those groups. So my sample, I'm going to include both of these. So this is a stratified random sample because I have two strata, two groups. And these are my students and faculty. And again, so I can separate people into these groups, take a simple random sample of 250 students and a simple random sample of 50 faculty members, and then kind of put those together, and I'll have a stratified random sample of 300 people. So that's what I mean by a stratified random sample. Again, I'm just taking, if there's certain groups that I want to make sure to hear from in my population, I can take a random sample of each one of those groups, put them together, and that's called a stratified random sample. Okay. And there's many other sampling designs, most of which we were not going to spend any time talking about, but if you are reading through a news article or something, you'll often hear them using something called a multi-stage sample, and this will incorporate several types of sampling into one scheme. And so again, it can get kind of complicated, and you have people like Gallup or the Pew Research Center. These are people that are paid to get these good sampling methods. So there's kind of more advanced than we'll talk about here in this class, just to let you know that those more advanced things are out there. And it's a big area of research too in the statistics department, as well as the survey sampling, where you're looking at all the issues that arise because of this. So this is a much bigger topic than we're going to get into in here. So finally, we always have to finish things off with cautions, right? So we talk about bad ways of doing things, good ways, but then we also want to kind of keep in mind other things to be aware of. So two main problems that we'll have with our surveys, as far as them being biased, are these notions of undercoverage and non-response. So again, kind of just what it sounds like. Undercoverage will happen if some groups in my population are left out of the process of choosing that sample. So again, kind of going back to maybe the 6 o'clock news survey example, I'm leaving out people who don't watch the news, but I'm also leaving out, sort of a bigger group that I'm leaving out is people who don't have a TV, for example, right? So maybe I'm sort of undercovering who, I'm sort of leaving people out sort of systematically there. I'm not even giving them a chance to be part of my sample. So that's what we mean by undercoverage, if I'm sort of leaving out certain groups of people. So this is like the So I'm just leaving out people who do not have a television. And let's do one more quick example of this. So just like we are right now. So if I want to find out how students at Ohio State feel about classes on Friday, a survey is given out to students during a Friday lecture. So what's wrong with that? Yeah.
Not everyone has Friday lecture.
Right. So not everyone has a Friday lecture. And what else? What's the more honest answer there? Yeah.
And the fact that they're already here, so they obviously don't have a problem with it.
Right. So people who are already here at a Friday lecture, well, presumably don't have a problem with it anyway, right? Everyone has a Friday lecture. And people who are here don't mind Friday lectures. So yeah, that idea, even if you do have a Friday lecture, not everyone's going to show up on Friday. So I'm just straight up leaving out several groups of people that might be important if I'm really wanting to answer this question. So that's undercoverage. The other thing that we want to be careful about is something called non-response, which, again, just what it sounds like. This is when I choose an individual to be in my simple random sample, but I simply can't get a hold of them, or they refuse to participate. So maybe they just, for whatever reason, don't want to be involved in my sample here. So example of this, simple example here is that suppose, again, if I want to add a technology fee to your already large student fees, I send out a survey by email to all the students enrolled in classes this term. What's wrong with that?
People can just choose to delete it and not respond.
Right. How many of you respond to every email you receive? Right. Nobody does that, right? So, people often delete or don't respond to emails. And this actually sort of gets back to the previous example too. What's another problem you guys can think of that's wrong with this? Yeah.
That maybe people with the only people that answer the email are people with strong opinions.
Okay, yeah. So again, if you respond to the email, you might have strong opinions. So strong will be so kind of getting back to that idea, absolutely, of voluntary response. I'm letting people elect in. And maybe sort of less of an issue in this case, but do you guys see a problem? I'm asking about a technology fee and I'm sending it out via email. That seems kind of funny to me. And again, presumably everybody at Ohio State has email access, but some people might have less frequent access, and depending on how long I have that survey going, again, just all around a bad way to collect information, but a very easy way, right? So that's why you get lots of emails about asking you for your opinion on things. Doesn't mean it's a good way of getting information. And then in addition to that, there's something that kind of the behavior of the respondent or if I'm the interviewer, that can cause response bias. So another example, if I'm sitting in here and I ask you, have you guys ever cheated on an exam? Will that give biased results? Yes. And that one's pretty obvious, right? Because kind of in the context here, if it's non-anonymous, then you're maybe not going to be perfectly honest with me about that. Maybe you will, and that's good too. So again, just keeping in mind that sort of the context of how the question is being asked can cause additional bias there. Oh no, you got to be kidding me. Wow, this is just not a good day to be having a lecture, I guess, is it? Well, I think the good news is that we're pretty much through these notes. So the last thing on your set of notes there is talking about the kind of taking that one step farther, is taking the wording of questions can also be very important. And I'll ask you which one of these two questions, I'll let you read them there instead of having them up here on the screen. Which of those two questions has neutral wording? So again, if I want a question that sort of doesn't introduce some sort of response bias like I have here, which of these has neutral wording? So the first one says, because you can vote, serve in the military, and be sent toward age 18, should the drinking age in Ohio be lowered to 18? That's my first choice. My second choice is, should the drinking age in Ohio be lowered to 18? So which one of those has neutral wording? How many think it's question 1? How many think it's question 2? Almost everybody. And both or neither? Well, yeah. So why is so you're right. Question B or choice B, question 2 is the neutral one. What's wrong with the first question there? Yeah.
It's like arguing for it, so you're automatically gonna think that it should be lowered.
Yeah. So the way it's phrased is kind of giving you an argument of why it should be lowered, right? Because you can do these other things at age 18, shouldn't you also be allowed to drink at age 18 as well? Yeah, exactly. So that's kind of before I even ask you the question, I'm sort of telling you what you should answer. Or I'm trying to convince you of a certain way of answering. Yeah. I guess it's a good time. This is just a bad day to be in this room, isn't it? So that brings us to the end of chapter 8. Do you guys have any questions you can think about as far as chapter 8 material goes? Okay. So we're about 10 minutes early here, which is okay. It's Friday. I think we can get out of here early. But first, if you would please, I wanted to take a chance to get some feedback from you guys. And now that I've talked about sampling, we can discuss the if this is a good or bad way. But what I'd like you guys to do, if you have an extra piece of scrap paper, just tear off a section of that, jot a few comments down. Please don't put your name on it. Anonymous is fine. But if you could comment on the technology in here, sort of my teaching, all of these things, anything you'd like me to know about how this class is going for you. And then you can make a pile up here maybe on this front table or something like that. Again, appreciate your honesty. And and after you do that, you guys are welcome to get out of here. Have a good rest of the weekend, and we'll see you guys next week.